Okay. Amber, can you see my screen? Can you hear
Yes,
me? Okay.
yes.
May I know here, if we know that the rows count equals 3 in this example array, may I know the values of I will be from what to what?
You mean the index?
Yes, the index I. Yes.
So it'll be 0 to 3, but then I mean 0 to 2 because you subtract it by
Yeah,
1.
excellent. Okay, what about J here?
Again, the same for J.
Excellent. Okay. So for every row, so this is an index for the rows, and this is the index for the columns. So for every row, when we are at row 0, we will run this loop, the inner loop, for one time. So how many times to be able to run, to be able to go through all this code, or to be able to go through all this 2D array for every row which is concerned or run by our outer loop, when I equals 0, we will actually run the inner loop. How many times we're going to run the inner loop here? We're going to run it for the number of columns here. So if we have 3 columns here, so we're going to run this code 3 times. So for every row, when I equals 0 here, we will start to change the value of J from 0, and then 1, and then 2. And then we increment. So once we reach end loop, then we go back again to increment the value of I. So we increase the value of I by 1, and then we will run the inner loop again for how many times? We will run it for J equals 0, 1, and 2. So when we go to the row here, which is row 1, at the index 1 here, we will run column 0, column 1, column 2. And then once we finish that, we reach here, we go back again to the outer loop, and we increase the I by 1. So I now become 2. So it means that we are coming to this row. And then again, we run J0, J1, J2. So it means that we run this loop for 3 times because we have 3 columns. And then we finish, and then we reach the end loop. Did I make it clear or still confusing to you?
No, I understood that, but what's the purpose of this code?
This code is to print all the elements of the 2D array. So if you see here, he put I is changing. I always refer to the number of row. J always refer to the number of column. Okay, so every time at this, so how are we going to print? We will print A11, A12, A13 first, and then we will, once we increase to the row 1, we will print 21, A21, A22, A23, and then we increase the row, then we print 31, 32, 33. So, but again, the purpose of the loop can be dictated by the code that you put inside the inner loop. In this specific code, you just take the element out from the 2D, you assign it to a variable, and you print it out in this specific code. But you can do something else. You can search for a number inside the 2D array. It is possible. Same like you have done it in the 1D array, and same like you have done it in the collection. So if I tell you, search for me this array, 2D array, for the number 7, and count, make a count. So you are able to put the code here inside.
Okay, so this code is basically to just find the element, or is it to just like see what's there in the row and columns?
in this specific, this line of code, these 2 lines of code is only for printing whatever inside the 2D array, only for printing.
Okay.
So because you see here, I mean, you see, they are just taking out whatever in the row and column and then printing out. But you have to understand. So this remain the same. The structure, the outer loop, inner loop is the same. The one that can change based on what we want to do is whatever we write inside. So these two lines, 1, 2, we change them based on what we want to do with the 2D array. Am I clear so far?
Yes. So the first lines and the last line remains the same when I have to find something that's in the array.
Yes, but just bear in mind that this is a way if I want to go row by row. Sometimes there is a requirement, yeah, to get you confused in the exam. They want to tell you, get me the data column by column. So at the moment we read this row, we get all the columns out. We read this row and we got all the columns out. But sometimes he asks you, no, he asks you to go to read all this first, and then after you finish all that, you read that, and then you read that. So how this will differ? So if I have a 2D array like that, 1, 2, 3, and then I have another one, 6, 4, 5. So this is my 2D array, okay? Not like that. So if I want to print it out like this way, so what I'm going to print out, you will see on the screen coming out 1, 2, 3, 6, 4, 5. That will be printed out. That is the output if I have this 2D array and I run this code. That will be printed out on the screen without, of course, without this and without this. This is just will be printed. Each number will be printed out like that. Okay? But I will show you now a code. What is the changes that you need to do to the code to actually print the columns first? So what is the column here? The column number 1 here is 1 and 6. Do you see this?
Yeah.
1 and 6.
Yes.
So I print that out. And then this is if I want to run column by column, not row by row. So, and then I will come here and then print 2 and 4, 2 and 4. And then I come here, I print 3 and 5. Okay, so what is the change that I will do to this loop to actually, instead of printing row by row, to print column by column? I will show you. But then I would actually ask you, have a look at this code and tell me what is the difference between this code and the previous code that we have.
The difference between the two?
If I mark here one, oh sorry, I need to use a different color. So here, line 1, line 2, line 3, line 4, line 5, line 6. What is the difference? Which line is actually different from the previous code, previous slide? Can you recognize anything here different?
I think the third one.
Third one, different?
Yeah.
Okay, we have a look at the previous code. Have a look here. Is it different?
No, it's the same.
So, okay, look more. Look one more time, please.
Could you please go back to the previous one?
Yeah, sure. Here.
Then could you go to the next one?
Mm-hmm.
I'm not sure.
You are smart. If you are not smart, I would haven't waited for you to actually give me a reply. Look one more time. The more effort you put, the more the information will stick to your brain. Have a detailed look at the loop itself.
The loop, okay. Then the next one.
So have a look at this loop. Of course, this doesn't have any colors, but the next one have colors. So
yeah,
look into detail about the index and the arrangement of the loop itself.
Could you just go to the next one more time?
Yeah.
Okay. I think the only difference that I can sort of tell is first it says, in the other one it says loop I, but then this one says loop J first.
Okay. What about, yes, that is excellent notice, yes. And when we said loop I first, we talk about the number of rows, right?
Yes.
Okay, and in the next slide, what we see here is what?
Oh, we see columns.
Columns. So he switched the loop. Instead of having the loop of rows first, we have the loop of columns first. So when we want to run a column by column like that, we need to make the outer loop through the columns first. But you see here, this J is where? So this J is always changing the column. And this I is always changing the rows, the index of the rows. So again, you want to run column by column. You want to print this one out first, and then the second column and third column, you have to put the outer loop for the column. Am I clear? Did I make myself clear, or is
no,
difficult?
could you explain it again?
Sure. So I would like to, you would like me to explain it here or go back to the previous one first?
Yes, the previous one first and then this one.
Okay, so basically this line of code say it's array like that, but then he write row and then column. I refer to the number of row. We put it here like that. And J refer to the number of column. So, but again, we start the outer loop for rows. When we do that, when we want to, so when we put the outer loop for rows, and then it means that the I will, now let me put it for you in a different way. I can tell you, okay, I can tell you like that because I already said before to you. So when I equals 0, put here I equal 0, okay? So it means that our array will look like that. So because I is the first thing that comes.
Yes.
This is outer loop, okay? So when we are at row 0, the inner loop will run. So it will change the J, but the I will remain always 0. So it will change the J to actually become, this is the J, and this is the value of the I. So here it will remain 0. Inside this loop, when we are printing, so J will change. We keep changing the J inside, but the I will remain the same. So here, so this code will cause that when you run for I equals 0, he will keep changing the number of j until he reach the last thing here in the column. And then after we end this loop, he will increment the value of the I to become 1. So we will have the row 1 here. And then we will change.
So I'll keep looping I till j changes.
You keep looping I until j changes. You keep looping I until the column number of column finish. You print all of them. You keep loop. So I mean, wait, no, wait. Let me correct that. This loop run only for one time, but this loop run for many times. Is that clear to you first?
So this code over here prints out the rows and columns, and then first it prints out one row and then the other column, or
it prints out one whole row first.
Okay, then it does the column.
But I mean, it will print row 0 first, and then it will go to row 1 first, and then print all of it, and then go to row 2 and print all of it. So when I equals 0, from this is given by the outer loop, I go to the inner loop. I don't come back to the I and change it until I reach 2, j equal 2. Is that more clearer or no? Here, j equals 0, j equal 1, j equal 2. When you are at I0, which is row 0, you have to run the inner loop, which do what? It will do these changes.
Okay, so it changes the column.
Yes, exactly. It changes the columns. Yes. When you change the column and you print out.
Oh, okay. So then in the second code, first it prints out the column, then the row.
Yes. So when you do that, so if we come here, let me try to clean things out. So here, since we have the outer loop for columns and the inner loop, so we start with j equals 0. So j, now we are starting with j equals 0. J equals 0 means that the outer loop will remain with j equals 0, but the column will change. So he will fix the j to 0, and then he will start to change the value of I, which represents the column. So it means, have a look here. So I will be changing this is 0, 1, 2. So I will print all the values at column 1. So when I'm at column 1, I want to print row 0, row 1, and row 2. So do you see here? Row 0, row 1, row 2. So that's why if I have an array like that, let me put it square so that you are aware of that. Let me remove that here. I put 7, 8, 10. So if this is my array, I would like to print 1, 6, 7 first. So here I will change it. I would like to print 1, 6, 7 first. Are you catching with me, or you're still lost here?
No, I get it now.
So, yeah. Are you able to tell me what did you get? No need to be shy and no need to worry. I can keep repeating until you are able to catch it. But just bear in mind, this is a new concept that I'm explaining to you. To fix that, we have to really do a lot of practice. If you catch 50 to 60% in the first time I explain it, it is totally fine. No worries about that. It's normal. Okay?
Okay.
Okay. So just tell me what you understand, so I can try to prepare more on the next sessions.
Yes, so for this one, it's the opposite of what was happening before. So the column, the J will keep looping till I changes. So the inner loop changes the I over here.
Okay, so the inner loop changes the I, which is the rows. Am I right?
Yes.
And the outer loop changes the columns. Clear?
Yeah. Yes.
So if you want to print row by row, you will put outer loop for rows or columns.
Sorry, could you repeat that?
Okay, if I want you to print row by row, so first of all, look at this title that I'm putting, looping column by column.
Yes.
And then look at this title, I write looping row by row. So they call it row measure order, the official naming for it in the syllabus, row measure order. If I want to print row measure order, it means I need to follow the red line that they put here. I print like that. I print like that. Okay. If I want to follow, if I want to loop by column measure order, I want to follow this light blue color here. So I print the column first like that, and then I go to the second column, and then I go to print the third column. So, okay, now my question to you, if I want to print row by row, I put the outer loop. This is the outer loop. This is outer loop, and this is the inner loop. So this is outer, and this is inner. If I want to print row by row, I put the outer loop to loop the columns, all the rows.
You want to loop the, okay,
row
so
by row.
Row by row. So it'll be loop I from 0 to rows -1.
Excellent, excellent. If you start to memorize that just for now, it is more than enough. Yes, that is good. Okay, and don't ever worry. It is typical. Programming takes time to build links in your brain and digest that. It's normal. Okay, don't worry. You are doing just fine. So I will use the remaining time to introduce you to something new. So I am doing something called interleafing. So I am discussing many topics with you so that your brain takes time to digest that. Let me show with you. No, let us go to the stack. So stacks is in your syllabus, am I right?
Yes.
Okay, do you remember anything about the stack that you took?
No.
Okay, can you guess what is the usage of a stack in a real world?
It's when you place something on top of something else.
Yes, perfect. And if you put books on top of each other, if you start to stack books on top of each other, so this is a stack. So if you memorize that, you will be able to differentiate it out from the queue. So the stack, when you put something on top here, so imagine this is the stack of books, and the first book you put here, and then you keep stacking, adding books on top of the stack like that. So if you put the last book here, this is a biology, and this is a book for the math. So if I ask you to take one book out, typically the only books that you are able to take it out at the moment is the bio, because it is the last one. So the last book that we put on the stack is the first book that we're going to take out. Correct or wrong? I repeat again.
No.
Okay, so after we remove the bio book, we will have the math book on top. So and if I have the computer science book here, are you able to take the computer science book before you take the math out? No, you're not allowed.
Yeah.
Okay, so you have to take the math book out before you take the computer science book. Okay, so this is basically how the stacks work. Remember it with this story, taking books out. And also there is another application for that, but I believe you will take that in the next in the remaining months after your exam. It's not now. So I will just give you an example. Do you know there is a back button in the browser? Do you know this button? Can you recognize this button in your browser?
Yes.
So this back button actually acts exactly like stack. So if I press the back button, it will take me to the immediate link that I have been in before the current link. So if I'm now at docs.google, so if I go back, I will go to immediately the previous website that I was visiting. I will not go to the first website that I visited. No, I will not go here. So imagine that this is a website, maybe YouTube. Okay, and you are at the moment at docs.google. So, and before you was visiting Gmail. So if you are now at docs.google, you press the back button, it will take you to the Gmail, because that was the previous link that you visited. The first one, it was YouTube. You will never go here unless you keep pressing back until you reach here to the YouTube. Did I manage to clarify that part to you?
Yes. So stacks is used to go to something.
Yes, it will. Once you remove something out, it will go to the previous link or even to the previous book that you have. Yes. So the most important thing here that it is called last in, first out. This is how it operates. Last in, first out. The last book is a bio book. It is the first book that you can take it out. Last in, first out.
Okay.
Okay. So we have three methods that we are able to use. We saw the methods that we use with the collection, and we have reset next, get next, and has next. This is all the methods with the collection, but here we only have three. So is empty is common with the collection, if you can remember. Is empty to check if the collection is empty or not. Here with the stacks, we have push, pop, and is empty. Okay, so if I want to add something to the stack, I say push. So I push something on the top. So I put a book on the top of the stack using push. Okay, if I want to remove something out of the stack, I use pop. Pop something out. But you have to understand, pop in this case is different from the collection. If you pop something out of the stack, you totally remove it and you can never get it back. Do you understand here?
Yes.
Okay, good. So if you pop something, you lose it. And then is empty is the same like the collection. So if I want to know if the stack is empty before I pop something out, I can do this. So if the name of my stack is OPS, so I say OPS is empty. If it return false, then I can do popping. I can pop something out because it's wrong to pop something out of the stack that is empty. If you have your stack that doesn't have anything here, it's totally empty. There is nothing here. So you cannot pop something out. You cannot take something out of an empty stack. So that will give you an error. This is wrong. So we have to check it is empty first or not before we pop something out. Am I clear so far?
Yes.
Okay. So this is the last thing that we're going to take. So just bear with me. Taking it and understanding only 40 or 50% is more than enough for me to understand. So I am showing you here the code. This is how I make a stack. And so we have a stack S, we define a stack S, and then we push inside the stack 10. So when we have a stack like that, this is a stack, I do the first push. So here 10. And then I do a second push. So here 20. And then I do a third push. So here I'm ending with 30 on top of the stack. Okay, clear?
Yes.
Okay, and then have a look here. There is something called peak. So peak can check what is the last element, what is the top element in the stack, but without removing. So peak, so if I use pop, it will totally remove the 30. But if I use peak, I will just look at the top element in the stack without removing it. So I can say s.peak, this is the name of the stack, is called s. I say s.peak, and then I store that in something called top element, and then I can print it out. So it will print to me 30. Am I able to use peak for 20? No. You cannot look beyond the top element in the stack. So you can repeat s.peak many times, but it will always print you 30. Did I manage to clear that point to you?
Yeah.
Or confusing? Tell me the truth.
It's a bit confusing.
The word peak is confusing, or is it peak is the one confusing to you? Can I know what you understand about peak so far?
No, I find peak confusing.
Okay, what about pop? I mean, look at this code and tell me if you can understand what pop is doing here.
So pop is kind of similar to reset, right? It just brings the top element.
I wouldn't say that it is like reset, because in the collection you can actually loop through the collection many times, but in the stack you can only loop through the stack only one time, because every time you call the pop here, you actually remove. So if I say pop, if I call pop now, and then I store whatever I get from pop in the removed element, he call it even here removed element. So now my stack become what? It become only having 20 and 10. So that
Okay,
is.
so you remove the element from the stack.
So it will remove the element from the stack. Yes. So every time you do a pop, you remove something out. So you will keep removing, you keep calling pop. So here, let me go back here. So I am pushing here. This is I'm pushing. So when I push, I add on top. So I push 3, it's added on top. I push 4, I add it on top. So this is 4. I push 5, it is added on top. I push 6, so 6 will be here inside. And then if I want to pop, so that will happen. So when I call pop, it will take 6 out because 6 was on top. And then I call another pop, it will take the 5 out. I call another pop, it will take the 4 out. And then until I call 2, then only 1 will be remaining. Did I manage to clarify that to you?
Yeah.
Can you repeat now what did you understand from me so that I have an idea about where is the issue so that I can also try to improve on the next class?
I'm not really sure about peak, but pop then removes the element that's on top.
What,
and then
what about push? What do you understand about push? Okay.
Sure.
Here, can you have a look what push is doing?
Yeah, push is putting elements in.
So it's adding elements to the stack. Am I right here?
Inserting them.
Okay. So okay. What about this code? Do you recognize that we are calling push 3 times?
Yes.
Okay.
Adding elements 3 times.
Okay. So when we adding elements 3 times, if I have a stack that have 3 places like that, so which one will be the first?
So it'll be 10.
10 from here or 10 from here?
10 from above. Or no, 10 from the bottom.
Okay.
And then 20, 30.
Okay. So the last element you push, it will be the one on top. Am I right?
Yes.
Okay, good. And then if I call now, if I call pop now, after I call it, what will be, how it looks like, how the stack will looks like?
So 30 will go, so it'll be 20 and 10.
20 and 10 like that. Is it clear?
Yes.
Okay, that's good. Let us stick to what we understand. Now, I would like to please check with you what is the meaning of that code, and that will be the last thing that we do.
Okay, it's checking if the stack has any elements inside.
In the current situation, S is like that because we already took the 30 out. So what do you think will be printed out? This or this?
The second one, output stack is not empty.
Okay. And do you think that that will run without an error? These 2 commands will run without an error?
Yeah.
So I'm able to even make the whole stack empty like that. So
yeah.
Okay, that is enough for me at the moment. So okay, I need your feedback, please.
Yeah.
What do you need me to change in the arrangement of the class to make it easier for you to understand and grab the topics what we are talking about?
No, I think this is fine. It just gets a little too much with all the meanings, but I do understand, so it's okay.
Okay, but promise me to try even you even if you write it wrong, the exercises help your brain to make the information stick. Okay.
Okay, I'll do the remaining 2 questions and the exercise that you give today. I'll do those.
Okay, that's good. Okay. See you next class. I will try my best to reply you if I'm able to arrange on Wednesday. Okay.
All right. Thank you.
Thanks a lot. Take care. Bye-bye.
Bye.